All right, all. In this video, we're going to talk about factoring ax squared plus bx plus c, which is a little bit different than what we talked about in the last section because of this a right here. This is the difference. We're going to start adding a coefficient next to our x squared term. So our essential question is, how can we factor the trinomial ax squared plus bx plus c into the product of two binomials? And that's all the set of notes is. So there's a method we can use to complete this. So if we have ax squared plus bx plus c, a process you can use to factor this is take a times c and so step one will be find two numbers that add to ac, to a times c. No, sorry, y'all. That add to b, just like we did in the last section, and that multiply to a times c. So that's going to be our first step. Because, y'all, one thing you can kind of do to help you visualize this is we're dealing with a times c and b. And we create a little, science test tube bottle. So we're dealing with this coefficient b, and the product of the coefficients a and c. And we're going to use all of these items to factor polynomials, to factor trinomials. So take a look at this example that I have right here. We're going to take 8 times negative 15. So if you type that into a calculator, maybe do that in your head. Remember that there are 15 minutes in an hour. An hour is 60 minutes. So that means we have 2 hours here, this will be a negative 120. And then we're going to be dealing with this product of 120 and the sum of 2. So we are looking for two numbers that multiply to 120. So we're looking for two numbers that multiply to negative 120 and add to 2. Now you might know this already. You might say, okay, well, negative 10 and 12 do, but I'm also going to show you this tool that you can use if you're kind of struggling with this, especially in this section as our numbers get much larger. So this is a product sum finder, so we can go down here, and I'll have the link to this on Canvas. So if our product is negative 120, that's what we want our product to be. Remember, product is what we're multiplying to be. Our product is negative 120, and we want these two numbers to also add to 2. We click find the product sum. This will give us two numbers that times to negative 120 and add to 2. So our numbers are negative 10 and 12. So we got negative 10 and 12 are our answers for these two numbers using the product sum finder. All right, and now step 2. What we'll do next is split the middle term, which is the x term. And what I mean by that is we're going to split this 2x up into a negative 10x and a 12x. So we're going to write 8x squared plus 12x minus 10x minus 15. So I replaced this 2x with a 12x minus a 10x because if we simplify this, what's 12x minus 10x? That's just 2x. So I didn't really change the value of this expression. We're just manipulating it so that we can factor it. And now we split the middle term. And step 3, we are going to factor both sides. So I'm going to kind of split this up into two different sections. So this is really 8x squared plus 12x minus 10x and 15. So I'm going to kind of split this up into two different halves. And we're going to factor each part. So this 8x squared plus 12x, we're going to factor this one first. What's the greatest common monomial term that goes into 8x squared and 12x? Well, the greatest common factor of 8 and 12 is 4. And then how many x's are in both of those? This one has 2 and this one has 1. That means we can factor out one of them. And then, let's see, if I divide this 8x squared by 4x, well, 8 divided by 4 is 2. X squared divided by x is just a 1x. Plus, what's 12x divided by 4x? I can write this out for those who need it. What's 12x divided by 4x? Well, that's just 3, and those x's cancel out, so this is just 2x plus 3. Now, y'all, the fun thing about these in this process is you are going to know in this step whether or not you are right. And we'll get to that. So let's take a look at this. Minus 10x plus 15. So we're always going to factor out the sign of the coefficient next to your x term. So that means the greatest common factor between 10 and 15 is 5. So I'm going to factor out a negative 5. So if I factor out a negative 5 from a negative 10x, this is like dividing by negative 5. But dividing both these by negative 5. So a negative 10x divided by negative 5 is a positive 2x. Negative 15 divided by negative 5 is a positive 3. Hey class, do you notice that this 2x plus 3 is a term in the first half and in the second half? And that's how you will know that you are on the right track and that your process is correct. All right, now we have one last step. We are going to completely factor this. So when these parentheses are the same, you know you're on the right track, and we're going to look at both sets of these parentheses. So we have a 2x plus 3. I'm going to factor out a 2x plus 3 from both these terms. All right? So we have a term here and a term here. I'm going to factor out a 2x plus 3. Well, if I divide this first term by 2x plus 3, these just cancel and we're left with a 4x. If I divide the second term by a 2x plus 3, again, these 2x plus 3 terms cancel out, and this is just a minus 5. And this is our solution. So this means that 8x squared plus 2x minus 15 is equal to 2x plus 3 times 4x minus 5. And you can double check this by foiling, by distributing this answer, and you should get the same thing up here. Or you can graph them both in Desmos, and they should be the same line. All right, now I have 6 more examples for us to work on. So we're just going to factor 6 different examples. All right, so 4x squared plus 32x plus 60. So remember, we're going to take the product of 4 and 60. So 4 times 60 is 240. So that means we need 2 numbers that multiply to 240 and add to 32. So I'm going to go find these 2 numbers. So I need 2 numbers that add to 240 and sum to 32. So we got 12 and 20. You see this? The results are 12 and 20. All right. So I'm just going to kind of write that up here. 12 and 20 are our solutions here, which means we can write this as 4x squared plus 20x plus 12x plus 60. So do you see how we just broke up that 32x into a 20x and a 12x? We didn't change the value of this expression. We're just manipulating it so that we can now factor. Now I'm going to split this up into 2 different parts and factor each part. So take a look at 4x squared plus 20x. What can we factor out of this binomial? Well, we can factor out a 4 because that's the greatest common the greatest common factor between 4 and 20. So we can factor out a 4 and an x because both those terms have an x. And if we take 4x squared divided by 4x, we are just left with an x plus If we take 20x divided by 4x, those x's will cancel, and we are just left with 5. All right, plus, what is the greatest common factor between 12 and 60? This is actually just 12. So let's see, so 12, we can factor out a 12, and then we're just left with an x plus 5. All right, so we know we're on the right track because we ended up with an x plus 5 from both of these halves of this expression. So now let's do one last step of factoring. So this is really just 4x plus 12 times x plus 5, because we just factored out that x plus 5. All right, y'all. Have we completely factored this? We have one step, actually. Take a look at these parentheses. Is there anything that we can factor out of 4x plus 12? Do they have any common factors? Yes, we can factor out a 4. And if we factor a 4 out of 4x, we're left with an x. If we factor a 4 out of 12, that's just a 3. And then this term doesn't change. So that means 4x squared plus 32x plus 60 factors to 4 times x plus 3 times x plus 5. Let's move to the second example. All right, let's find the product of 4 and 3. This is 12, so we need two numbers that multiply to 12 and add to negative 7. So multiply to 12 and add to negative 7. So that is negative 4 and negative 3. All right, negative 4 and negative 3. So that means our function is going to become 4x squared minus 4x minus 3x plus 3. Now let's take each of these. Let's split this expression in half and factor each half. So from this first term, this 4x squared minus 4x, we can factor out a 4x. And if I take this first term divided by 4x, we're just left with an x. If I take this term divided by 4x, we are left with a negative 1. All right, now for the second binomial, I'm going to factor out a negative 3. Because the greatest common factor of negative 3 and 3 is 3. So we're going to factor out a negative 3. And on the first term, we're going to be left with an x. And what's 3 divided by negative 3? That's a negative 1. All right, y'all. Let's do one last factoring step. So we know that this is also equal to 4x minus 3 times x minus 1, because we just can factor out that x minus 1 term. And take a look at these sets of parentheses. Can we factor anything else out? Nope. So this is our answer. All right. Got 4 more examples and then an application. And that's it for this section. That's it for this video. So let's do 3 times negative 6. This is negative 18. So we need two numbers that multiply to negative 18 and add to negative 7. So let's see. Product, we want to be negative 18. And we want the sum to be negative 7. The results are negative 9 and 2. So I'm just going to go and write that up here, negative 9 and 2. So we can write this as 3x squared minus 9x plus 2x minus 6. All right, now we're going to factor each of these binomial pairs. So we can factor out of 3x squared minus 9x, well, common factor of 3 and 9 is 3. And we can also factor out an x because both terms have an x. So we factor out a 3x. If we take 3x squared divided by 3x, we are left with an x. If we take negative 9x divided by 3x, we're just left with a negative 3. Plus, all right, 2x minus 6. We can factor out the greatest common factor of 2 and 6, which is 2. And 2x divided by 2 is just an x. And then what's negative 6 divided by 2? Well, that's just a negative 3. All right, we've got terms in parentheses that are the same, so we know we're on the right track. And we can now simplify this, or we can factor out that x minus 3, and we get 3x plus 2 times x minus 3 is the factored version of 3x squared minus 7x minus 6. All right, let's take a look at this next example. 2 times negative 15 is negative 30. We need two numbers that multiply to negative 30 and add to x. I'm going to go ahead and tell you that these are 6 and negative 5. Because 6 times negative 5 is negative 30. 6 plus negative 5 is 1. So our expression now becomes 2x squared plus 6x minus 5x minus 15. And we'll factor each term separately, or each binomial pair separately. So let's factor 2x squared plus 6x. Well, the greatest common factor of 2 and 6 is 2. We can also factor out an x from both of those terms. So now it's 2x squared divided by 2x. That's just an x. What is 6x divided by 2x? 6 divided by 2 is 3. X divided by x is just 1. So this is just x plus 3. All right, from this next one, we're going to factor out a negative number because this coefficient next to x is negative. And what's the greatest common factor between 5x and 15? Well, it's 5. So we're going to factor out a negative 5. So negative 5x divided by negative 5 is just an x. Negative 15 divided by negative 5, well, that's a positive 3. All right, and now these two terms are the same, so we know we're on the right track. And our result is, we can factor out that x plus 3, and we get 2x minus 5 times x plus 3. We can't factor any of these binomials anymore, so therefore, that is our answer. All right, we got two more abstract examples, and then we'll do a more concrete application example. So let's take negative 9x squared minus 3x plus 2. What is negative 9 times 2? Well, that's negative 18. Therefore, we need two numbers that multiply to negative 18 and add to negative 3. I'm going to tell you those numbers are 3 and negative 6. Because 3 times negative 6 is negative 18, and 3 plus negative 6 is negative 3. And just keep in mind, you can keep using that product calculator if you choose to do so for these types of problems. All right, so this means we're going to split up this expression into 9x squared plus 3x minus 6x plus 2. Split this into halves. All right, this first term, we have a negative 9x squared plus a 3x. Well, what's the greatest common factor between 9 and 3? That's 3. And since this first term is negative, I'm going to factor out a negative 3x, because we can also factor out an x out of both of these terms. So if I factor out a negative 3x, let's see, negative 9x squared divided by 3x. Well, negative 9 divided by negative 3, that's a positive 3. And then x squared divided by x, that's just 1x. All right. Now 3x divided by negative 3x, well, that's just negative 1. It's minus 1. All right, and now from the 6x plus 2, we're going to factor out the greatest common factor between 6 and 2, which is 2. And since we're dealing with the subtraction right here, I'm going to factor out a negative 2. So what is negative 6x divided by negative 2? Well, that is a positive 3x. And what is this 2 divided by this negative 2? That is negative 1. So we have two terms with 3x minus 1. We are on the right track. In our last step, we factor out that 3x minus 1. And we are left with a negative 3x minus 2. All right, last example. We've got negative 3 times negative 2, which is a positive 6. So we need two numbers that multiply to 6 and add to 7. And those two numbers are 6 and 1. Therefore, we're going to rewrite this expression to be negative 3x squared plus 6x plus 1x minus 2. All right, let's do some factoring. From our first half of this expression, we can factor out a negative 3x. And if we take out a negative 3x from the first term, we are left with just an x. And if we take out a negative 3x from the second term, we are left with a negative 2. All right, and how about the second one? We actually can't factor anything out of this. This is as simple as it gets. So this is really just plus x minus 2. Keep in mind, this is really like plus 1 times x minus 2. Now we can factor out this x minus 2 term. We factor out x minus 2, and then we're left with a negative 3x here plus a 1 over here. And that is our solution. So now you can do the opposite of FOIL, and you can factor any trinomial. Congratulations. Let's take a look at this last example, and then this will be it for this video. So the length of a rectangular state park is 2 miles longer than twice the width. The area of the park is 84 square miles. What is the width of the park? Alrighty, I'll get my green so we can draw this park. So this park is a rectangle. All right, we've got the width. The length of the park is 2 miles longer than twice the width. So that means twice the width we can represent by 2w. And 2 miles longer, that means that our length is really just 2w plus 2. It's 2 miles longer than twice the width. And the area is 84 square miles. Alrighty. Let's go ahead and try to solve for w. We're just looking for what is the width of the park. All right, well, we know that the area of a rectangle is the base times the height. So the area of our rectangle, we already know, this is 84 square miles. This is equal to, oh, I shouldn't say, I should have said length times width, shouldn't have I? So width times the length. Our width is just w, and our length we can represent by 2w plus 2. All right, let's go ahead and distribute this w. We're trying to solve for w now. So let's say 84 is equal to 2w squared, because that's what w times 2w is. And then what's w times 2? That's just 2w. Now, I want to set this equal to 0, because then we can factor it and then set each of those binomials equal to 0, so then we can solve for w. So let's subtract 84 from both sides. So we get 0 is equal to 2w squared plus 2w minus 84. Let's factor this. So 2 times negative 84, that is a negative 168. So we need two numbers that multiply to negative 168 and add to 2. So multiply to negative 168 and add to 2. And our calculator says these numbers are negative 12 and 14. So I'm just going to write that up here. Negative 12 and 14 are our numbers here. All right. Nope, I'll write that down here. Negative 12 and 14. So we can write this function as 0 equals 2w squared minus 12w plus 14w minus 84. All right, y'all. Same process as what we've been doing. Let's divide this up into 2 equal parts, or to 2 halves. I'm going to go ahead and start working up here. So this means that 0 is equal to, we can factor out a 2w from 2w squared minus 12w. And when we do that, we are left with a w minus 6. And we have a plus sign. Now let's factor something out of 14 and 84. So I'm going to help you out with this one, because I know my facts of 14. We can factor out 14 from both of these, and we're left with w minus 6. All right, let me draw my park again over here. Okay. So now, let's factor out that w minus 6 from both terms. So we are ending up with a w minus 6 times 2w plus 14. All right, now our zero product property says that we can set each of these terms equal to 0, and that will give us values of w that will get this entire product equal 0. So that means we can set w minus 6 equal to 0 and 2w plus 14 equal to 0. So to solve for w, we add 6 to both sides on this one. So we get w is equal to 6. And for the second part, let's solve for w. So let's subtract 14 from both sides. So that means 2w equals negative 14. And then if we divide both sides by 2, then it means w is equal to negative 7. So the width of our park can either be 6 or negative 7. Negative 7 does not make sense in the context of this problem, does it? That means we can rule this out because we can't have a negative width. Now, if I give you a 7-foot cake, I can't give you a negative 7-foot cake. Okay, so that means our width is 6. So that means our width is 6 miles. All right, y'all. Let's double check this. If our width is 6, that means our length is 2 times 6 plus 2, which is 14. Now, is 6 times 14 84? You bet it is. So that means the area is 84 with a width of 6 and a length of 14. And y'all, that is it for this video. That is it for factoring ax squared plus bx plus c. This is not easy stuff, so please reach out if you need help at all or have any questions. Join my office hours. I have those 3 days a week. Ask me to select you for WIN. Or just stop in before or after school. I'm always here. So just let me know what you need and I'm always happy to help out. So that's it for this video. And yeah, I hope you have a good day and a good weekend.